Hello guys, in this recording I'm going to talk about the pathogenesis of pulmonary tuberculosis and the fate of it. Pulmonary tuberculosis is caused by Mycobacterium tuberculosis bacteria. It is a bacillus, which is rod-shaped bacteria, and acid-fast. The acid-fastness properties in the bacterium is helped by the presence of mycolic acid content in their cell wall. The mycobacterium is transferred from one person to another via infected aerosolized sputum which has been coughed out by an infected person. The infected aerosol is then inhaled by another person and this will cause him or her to become infected. In the lung, the mycobacterium is detected and engulfed by the alveolar and also airway macrophages by the process of phagocytosis. These macrophages are not activated yet, so the mycobacterium will remain viable or alive within the macrophages. These macrophages can either remain in the lung parenchyma or being carried into the regional lymph nodes. For example, in this case, the perihilar lymph nodes. The macrophages release interleukin-12 and present the mycobacterium antigen to the T cells. These two actions by the macrophages turn T cells into T helper cells. T helper cells is then release gamma interferon, which is important to activate the macrophages. Activated macrophages produce number 1, phagolysosome maturation and activation, number 2, production of nitric oxide, number 3, production of reactive oxygen species, autophagy, and the last one, release of tumor necrotic factors and chemokines. These changes will destroy the mycobacteria that are present within the macrophages, but due to the toughness of the mycobacterium cells wall, not all of them are destroyed. Some, which is fortunate but unfortunate for the host, still survive within the macrophages. The release of tumor necrotic factors and chemokines will recruit monocytes and lymphocytes from the circulation to surround the infected macrophages. Monocytes, under the stimulation by the tumor necrotic factor and chemokines, will transform into epithelioid cells, and the action will kill and destroy the infected macrophages. The arrangement of necrotic macrophages at the center that are surrounded by the epithelioid cells and activated lymphocytes are named Epithelia Granuloma. The collection of abundant granulomas can be seen grossly in the lung parenchyma as gone focus or as an enlarged perihilar lymph nodes. But if both lesions are present, they are called gone complex. Mycobacterium tuberculosis infection is an unexposed person is called primary tuberculosis infection, whereas the same infection or reactivation of the mycobacterium in an exposed person is named secondary tuberculosis infection. So what happened in a person after he or she had been infected by the primary tuberculosis? There are 3 consequences after being infected by the bacteria. Number 1, the tuberculosis infection can heal and leave scars in the affected lung parenchyma and also in the perihilar lymph nodes. Number 2, the tuberculosis infection can remain dormant in the latent phase. Number 3, the tuberculosis infection can become worsened and progressive, and this causes either local destruction or it can spread via hematogenous route and cause tuberculosis infection to the other organ, for example in liver, in spleen, and also in kidney. Reinfection or reactivation of pulmonary tuberculosis is called secondary tuberculosis infection. It happens in a person who is previously been infected by pulmonary tuberculosis. The person who have been infected by a new mycobacterium, or the infection might be from a latent phase primary tuberculosis. Secondary tuberculosis cause localized caseating destruction. It is in the lung, or it can be become progressive secondary tuberculosis that is spread by hematogenous route and seeded in the liver, spleen, and also kidney. The magnitude of the secondary tuberculosis is extreme. This is due to the presence of the memory T cells that help in increasing the immune reaction. That is why we can see extensive caseating tuberculosis mainly in secondary tuberculosis. I hope this simple explanation will help you in the understanding the pathogenesis and fate of pulmonary tuberculosis. Till we meet again, goodbye and good luck. I'm Dr. Sparger.